Make sure you've got something that you can use to add some color. I would have a compass or some sort of circle creation device. Have a straight edge for when you need to create things. So this target, learning target number one out of this statement. Number one learning target, it said we're going to identify line segments, lines, and angles that are associated with the interior and exterior angles of circles. We're going to make conjectures. That's the next one. We're going to make conjectures about vertical angles, alternate interior angles, angles, and points on the perpendicular bisector of line segments in order to write theorems. So start off with highlighting the habits of mind. Let's reason abstractly and quantitatively. Let's construct viable arguments and critique the reasoning of others. That's what it is to be a mathematician, okay? Along with some other things too. Use your geometric knowledge to make a few conjectures. For example, consider the circle and triangle that Josh created. Nice job, Josh. That looks amazing. Angles, POM and DOB are vertical angles. Do you know where angle POM is? Sketch it in, highlight it in. Angle POM is POM, this angle right there. And DOB are vertical angles. So DOB, this angle. All right, cool. Nice job. Thank you, Josh. Let's go with the next one. Angle BOM. So BOM. And we should highlight that in. So BOM, 3 letters. Highlighted a different color. And POD, great band from the early 2000s. Shout out. So POD, there it is. Those angles, they create vertical angles. I need you to spot that. All right, that's a vocabulary word for us. All right, here we go. Faith and Trey each made a conjecture about the measures of vertical angles. Let's consider their conjectures and determine who's correct and explain why the other conjecture is incorrect. Here's what Faith says. All vertical angles are congruent and measure 90 degrees. Ooh, measure 90 degrees. Trey says all vertical angles are congruent. They both say the same thing. All vertical angles are congruent. That's such a strong statement, and they both say it. I'm going to highlight it. All vertical angles are congruent. All vertical angles are congruent. But is Faith right? Do they have to equal 90 degrees? These do. These absolutely do. Can you construct another example just to kind of confirm Faith is right? Yeah, of course, Faith. Here you go. Here's an example. If I draw a line like that, and then I draw a line like this. There's vertical angle number 1. There it is. They look like 90 degrees. Yeah, sure. I think Faith is on point. She's got it. Trey says, no, all vertical angles are congruent. All that Trey has to do, all that you have to do if you side with Trey, is produce another example. Produce another example where those vertical angles are not 90 degrees. I bet you're thinking about it right now. Like, can I just made it like that? I hope you did. These are vertical angles. You have an angle up here and an angle down there. Definitely not 90 degrees. You know, like a piece of paper forms a 90-degree corner. And when you try to like line it up, nah, it doesn't line up perfectly. It's like wider right there or skinnier right there. So for that reason, not 90. Trey's right. Trey's right. Okay. Let's go to page 207. This activity, quick and to the point. Okay, consider the central angles MOP and POD and their arcs MP and PD. What are they talking about? Oh, they're talking about the circle. They're talking about the circle over here. Okay, so we're going to consider the circle that Josh constructed. We're going to consider MOP. That's this angle right here, right? And POD. That's this angle right here. I already see something that I need you to know about. When you put two angles together and the result is that they form a line, heads up, note, angle MOP and angle POD form a vocab word time linear pair, which means they add to 180 or sum. They're using the word sum. So they sum, which add, right, to 180. Okay. What can you conjecture then about the measure of the arc MP plus the measure of the arc PD? And honestly, They came from 90 degrees plus 90 degrees, so therefore together they also add to 180 degrees. Those two arcs form a half circle. See? MP, PD, half circle created. So therefore they have to add up as arcs to 180 degrees. All right, let's go. Number 3. Last question on this activity. Construct line EL. I know it's a line because of the arrows. Construct line EL through the center of the circle parallel to line PM. This is a secant line. All right, this will also be a secant line, but because it goes through the center, it's probably going to help form the diameter. So that angle EOP and angle LOM are both acute angles. What? Wait, turn it. Maybe like that. You got to kind of like get it lined up, right? Is that parallel? This is what we did back in activity, like in the last module. We had a line and a point not on the line, and then we want to construct. There's like a formal way to do it. Maybe like with GeoGebra, like using that online website, that'd be so much better than this. But this is okay enough. Okay, so that, I need to put E here. Right, it says EL. We got to have letters. EL. All right, I did kind of eyeball it, which means I kind of looked at it, and that looked pretty close. I could be more precise. I should be more precise, but whatever. Angle EOP. So that's angle EOP. That's this angle right there. Highlight. Come on now. Do math in color. Angle EOP. There it is. Boom. And angle LOM. So LOM. These two. Oh my gosh. This angle and this. Oh, whoa. Okay, wait. So there's one angle, two angles, and three angles. And they all form a straight line because they all, meet at the middle of the circle. So the first angle and the second angle and the third angle they form a line. We could say they're a linear pair, but there's three of them. We'll say they're a linear pair. So because they form a linear pair, the measure of angle EOP plus the measure of angle POM plus the measure of angle MOL, or they use LOM, LOM, they have to equal 180. They form a line. Wait, we know what POM is. POM is a 90-degree angle. So then I know right away POM makes a 90. And if I take away 90 from both of these expressions, I get 90 equals the measure of what's left. Angle EOP plus the measure of angle LOM. All right, I'm taking that 90-degree angle away from the group of three. That means I'm taking 90 away from the sum total of 180 degrees. Yikes. Okay, well, whatever the angles are, together they add up to 90 degrees. And then this other 90-degree angle can come back into the mix, and together all add up to our math answer in geometry, 180 degrees. Okay, let's do this. PMO we know is 45 degrees because of the triangle that's created. EOD. Oh, bro, these are parallel lines. And so this angle, highlight pink time, this angle right here, and then EOD, this angle right here. They both open the same way. They're created when parallel lines are crossed by another line. So then they're both 45 degrees because they are, what's the word? Corresponding angles. All right. MPO. Let's bring in the yellow highlight. MPO. That must be that angle up in the corner. And then POE. So POE. Oh, bro, this is the one we're looking at, how you can form specific types. Dude, them reading straight off that second learning goal, way back on page 201, the second learning goal. Make conjectures about vertical angles, alternate interior angles, corresponding angles, and points on the perpendicular bisector. This is alternate interior angles. Between these two parallel lines are these two angles, but they're on opposite sides of the same line. So because they're on opposite sides, that makes the word alternate. Because they're between the two parallel lines, that makes them interior angles. And then this was a 45 degree because it's part of that triangle with a 45 degree angle. So then that makes the other one. They're both the same measure, 45 degrees. Is there another angle pair that we could talk about? If this is a 45 degree angle, POE, how about angle POE? I'm right away, just spitting right into it. Here we go. Angle POE and angle LOB. 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 Do you recognize them? Two lines that cross. They form angles on either side of their corners. Do you know what those two angles are called? They are called vertical angles. And that makes them congruent. There we go. Boom. Thanks for watching this video. I know it's a long one. Way to stick with it to the end.